Word ladder. A ladder you can climb into a dream company. Alright, let's get started. Wait, what's going on? Okay. Given two words, begin word and end word, and a dictionary's words list, find the length of the shortest transformation sequence from begin word to end word, such that only one letter can be changed at a time, and each transformed word must exist in the word list. Note that begin word is not a transformed world. This is like tongue twister. Note that begin word is not a transformed word. For example, given the begin word is hit and the end word we have cock. Word list we have hot, dot, dog, lot, log, and cock. What does that mean? Anyways, as one shortest, if you know what that means, please comment below. As one shortest transformation is hit, hot, dog, dot, dog, and cock, and return its length 5. And note return 0 if there is no such transformation sequence, and all words. Here, my microphone is slipping. Okay. Alright. Return 0 if there is no such transformation sequence. All words have the same length. All words contain only lowercase alphabet characters. You may assume no duplicates in the word list. You may assume begin word and end word are non-empty and are not the same. Okay, so these are pretty good assumptions that saves us a lot of time. Now, all words have the same length, so we don't need to consider complicated situations where we have to have hot or hotter. Now, okay, so alright, how much time did we spend on reading the questions? A couple minutes, alright? So, if we were to approach this, then first of all, if we were do it in our just in our brain, if we were to solve it with our brain instead of code, we would just first try to find the words that are one added distance from the begin word. For example, we would eyeball through this, and then we would find, okay, hot, and then we'll see, okay, hot is actually one added distance from hit. Now, and then based off of hot, we will look at the next one added distance word, which is hot, which is dot and dot, right? So we have dot and lot. Okay, so dot and lot are one added distance from hot. Okay, so now we have dot and lot as our base, and we can start from dot. So one added distance from dot is, okay, we have dog and that's it. And so for lot at one added distance does not have anything. Oh, have hot, but we already visited hot, so so hot lot is pretty much useless. So from dot and lot we got dog. Okay, so dog. So far we have been through 4 added distances all the way from hit. Okay, so dog is our fourth degree distance from hit. Now, dog, the next one added distance is, cock. I'm sorry, I didn't mean to cock. No, wait, how do you pronounce this? Cog. Cog? Anyways, and I think we have log already. So this is how we found cog. You know what? I'll just call it COG, okay? Because this sounds weird. COG, okay? And then now by far we have traveled 5 edit distances all the way from hit and to cog. And okay, this reminds me of a graph, okay? So we are moving step by step, one edit distance by one edit distance from each word. So this looks like a graph, and also I think we can approach this with breadth first search. So we're going to be using a set to mark the visited words, and then a queue to be the current layer of the words that we have visited, and the word date is going to be our unvisited set. So whenever we visit a word, we will remove that from the dictionary. Okay. So, but what if the start word, the begin word, okay, let me see how much time. So what if the begin word is also contained in the dictionary? So does it matter? So if it doesn't contain, it's okay. But if it's I guess we can, if it's contained in dictionary, then one letter can be changed at all time. It's not a transform word. Begin word is not a transform word. It must exist. Each transform word must exist in the word list. So I guess because at the beginning we can do an edge case check. The check for the edge case, which is begin word is contained a word dictionary. If that is the case, then we'll just remove that. Okay, so I guess without further ado, we can start coding. Okay, so first of all, we need a queue to store. Now, first of all we need a visited list. We need a visited set, so we're gonna have string, and we're gonna have visited, and we have new HashSet, and we have string. Now we also need a queue, which is going to be linked list. Well, actually it's a list, and we have string, and call it queue, new queue, because we are using the list interface. All right, so now we need to, first of all, we need to convert this. Okay, first of all, let me see, can I just directly remove, so first of all, we need to convert this list to a set. So we'll have to have this set. Do we need the list? Do we need it as a list? I don't think so. Okay. So this is unvisited. It's going to be new HashSet string, and we're going to put the word list into it. Okay. So next I think we need to remove begin word, because we don't want that word in the dictionary, right? So because if it's a dictionary, then there's no, well, why would it be in the dictionary? Okay, I'll just remove it. So unvisited is going to remove. Okay, if what will happen if I remove an element that doesn't exist? So let me check. Java 8 and hash set. Wait, we have Java 9 already? I guess I'm outdated yet. Remove specific remove such a if this contains such a return true. If it doesn't, if then wants to return. Well, okay, I guess it will return false if it doesn't contain it. Okay, all right, we gotta speed up. We gotta hurry up, man. I feel like we don't have much time. All right, so first of all, we unvisited. We are going to remove the end word. Okay, so I'm sorry, the begin word. All right, so wait, are they going to be? Is it guaranteed that both going to be contained in the sequence from the length of the sequence only length? If there's no such, each word will exist. Each transformer must exist in the word list. Know that begin word is not a transform word. So what if end word is not contained in the word dict? Right? Remove this. Okay, so if word list, now hold on, if unvisited doesn't contain end word, then we'll just return false, because what the heck are you doing? You don't even contain this word, and then what are we looking for? All right, so and then okay, now here's the thing. We need to start iterating this queue, right? We need to start building this graph. Okay, so first of all, not yet, we need to insert. Now first of all, let's have a counter to count, say, distance, to count the distance from the begin word to the current word. And first of all, we'll add q to, this is, I think it's pop and push, right? For q, it is pull and add. Okay, offer, I think it's offer. Okay, so for q, we have offer, and we're going to offer the begin word, and while q size is not equal to 0. All right. Okay, so first thing first, we need to, so of course we're gonna pop this, and so temp will be the q of the first element of the queue. I think someone's working around here. Anyways, so the first element of the queue, all right? And then next, we are going to check okay, so sorry, I think I'm wrong. Okay, so first of all, we need to go through the word list to see if, oh wait, hold on, yeah, you were right, yeah, sorry, this is, yep, this is, what am I doing? Yep, so we need to go through, so we'll have poll, and we will change the characters, or change the characters one by one, and then see if it's contained in the word list. So for character char, for char ch word to card array. Okay. And then we need to keep track of the size. So I'm doing this because we are getting the distance of the current layer. So we should keep track of the size of the cube. And this will be I less than size. I plus plus. And we will pull the first word, and then for each one, each character, we will, now first of all, we'll compare it. So let's convert it to a character array first. So let's convert it to a character array, so that for each array, for each character, sorry, I'm just a little bit tired. For each character, we're going to modify it. To make it one distance away from the original, from word. Okay, so j is equal to 0 and j is less than 26 because we have 26 letters, and j plus plus. And then we'll have word. Now first of all, I forgot one thing, is there's another for loop. So I'll change this to k. So this, how much time I have left? Okay, 11 minutes, all right. So we have j, hij, hij. Okay, j, we have j is 0 and j is less than word.length. And we have j plus plus. Okay. So for every character, excuse me. So for every character, for each letter, hold on. Let me match the parentheses, the curly braces first. All right. So for everyone, we are going to change it one character away, right? So we are, how do we change it? So we are going to add k and then minus, so we should module, right? So we should change it to to a plus Okay. Okay, you might be wondering, okay, what if I have the same word? Because what if this is B and then A plus 1 is becomes B, so this is changing and not changing anything. That's okay, because when we are visiting this word, it's already been eliminated from the unvisited set. Okay, so now, so if so we better to create a temporary array to, it's got to be a new one. So character will be temp will be word. So now that we have changed it, we need to reset it back for the next one. So temp word, and after that we will change it back. Okay, so and then word will be converted. I'll say, can we convert a word array to a string? I'll say call it next word. Is going to be word to string. Is that a function? New string, I'll put word into. Okay, so and the next one is if unvisited contains this should be 1. So if unvisited contains next word, right? So if it contains this next word, then if it doesn't contain, we do nothing, right? If it contains this word, and if next word is equals or equals if next word equals to n word, then what do? We just return the result. This is what we want. Return distance. Okay, so that's perfect. But if it's not equal, then we'll do two things. First, it's been visited, so we'll get rid of it from visited. So first of all, we'll add it to the queue. Next word. And then we'll get rid of it from the unvisited. Okay, so and then we'll reset it back to and then we'll reset it back to this word. Okay. And then after this Q for word is equal to word length size. Okay, so after this for loop, after we have iterated through this layer of the first layer, right? We'll increase the distance. And then after that, so we will return 0 because we can't find anything after we have iterated through the verdict. Now, we've got 3 minutes, so I'm not sure if it's correct. Q is abstract. Okay, so my bad. Should be Q, and this implementation should be linked list. Okay. I'll convert it to car character. How about that? Possible loss from int to car. Okay. Convert int to character. I'm right. I don't know what was wrong. Okay, so maybe I should do this. This is funny. All right, so I guess I'm missing one layer. That motherfucker. Wait, is it like 2? Okay, so if we have why I'm off 1 by 1. Okay, okay, we have the first distance layer is 1, and then how about just change it to 2? Okay, this is ridiculous, but 5. Okay, so let me submit it. I hope I can pass. Accept it. Oh my god, this is ridiculous. Oh my god. Okay, I don't even know why. Okay, I changed it to, why is it 2 though? Oh, this is ridiculous. I'm sorry, I'm just really tired today, and it's been a long day because I was also fixing a bug. Well, not bug, but a new functionality for my job. Yes, I do have a job. So distance is 2. So why is it 2 then? Oh, I guess I'm time out. Hit 1, 2, 3, 4, 5. Oh, so the begin word itself counts as 1. So that makes sense because I didn't count the begin word. Okay, so yep, shut up. Yep. So I didn't. So yeah. So you should count in this question. You should count the begin word. Anyways, so it's a pretty typical question, typical breakfast search question, and what you need to do is just to. I think this part is very important. You need to keep track of the size first. Yeah. So you need to keep track of the size to 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 count the added distance layer by layer. Anyways, it was fun and I got accepted. And hopefully you enjoyed this episode and happy coding. I'll see you next time. Bye bye.